everyone. In this video, we are going to practice on the multiple choice question on the topic method of variation of parameter. Taking the first example, in this example, we need to find the general solution of this differential equation. You can check it. We cannot answer this differential equation without the help of method of variation of parameter because the right hand side function is a cosecant x. And we don't have any particular form for this to find the particular integral. Therefore, we will find its solution with the help of method of variation of parameter. As per the statement, we need to find the general solution. General solution means it contains the complementary solution as well as the particular integral. Complementary solution must contain a two constant as it is a second order derivative. So we can clearly discard the option A because in this case we are not having any complementary function, or we can say that we are not getting any term that contain the arbitrary constant. Similarly, we can discard the option C. It contains only complementary function, not a particular integral. Now either option B is correct or a D option. In the option B, you can check it with sin x term, we have log of sin x. Even here we have sin x term with log of sin x. So we just need to find whether we have this term in a particular integral or not. If not, then B option is correct, otherwise D option is correct. How we are writing the particular integral in this case? We write a of x into first function plus b of x into second function. Now what is y1 and y2? That we can extract with the help of this option. In both the option we have cos x and sin x. So definitely they are the linear independent solution for the homogeneous differential equation. Let's suppose we are taking here as a y1 cos of x and here y2 as the sin of x. Now, from the option B and D, this bx we can directly fetch it, that is a log of sin x. Same term is mentioned here. We just need to find what is the value of ax. Whether this is a 0, if this is a 0, option B is correct. If this is not is equal to 0, then option D is correct. Now, how to write this ax? Ax is calculated as minus integration x upon Wronskian of the function. Rather than taking a cos x function, we take sine of x. Now what is the x? X is right hand side term divided by 1. That is equal to minus cosecant of x divided by Wronskian. So if this is a y1 function and this is a y2 function, what is a Wronskian in this case? Calculate that. So Wronskian in this case is equal to y1 function cos of x, y2 function is a sin of x, cos x derivative is minus sin x derivative is cos x. This is equal to cos square x minus of minus plus sin square x, that is equal to 1. So the Wronskian value in this case is 1. This sin of x as it is. This can be mentioned as minus cosecant is written as 1 by sin of x into sin of x. So sin x is get cancelled with sin. So we have only 1 here. What is the integration of 1? That is the x. And this negative sign is as it is. So this is the value of a of x. So here we can write, we are getting the term minus x cos of x. That is only present in the option D. Hence, option D is correct and B is incorrect. So there is no need to calculate the bx in this case because the bx term both is same. Taking the next example, the complementary function of this differential equation is this. What is the value of a using the variation of parameter where particular integral is defined by this form? From here, we need to find the value of a. A is written as minus integration x upon Wronskian of the function into cos of 4x. So we will not take sine 4x, we will take the second function cos 4x. So we need to find the integration here. What is the x in this case? That is the 32 secant 2 of x divided by coefficient of second order derivative, that is the 1. Now what is the Wronskian? This is the complementary function. So let's suppose this is a y1 and this is the y2. According to this, Wronskian is calculated as first function sine of 4x, second function cos of 4x. Derivative of sine is cos 4x into 4 and the derivative of cos is minus sine 4x into 4. Take the determinant of this. This gives us minus 4 sine square 4 of x minus 4 cos square 4 of x. Take minus 4 outside. We have sine square 4 of x plus cos square 4 of x. This is equal to 1. So we are getting the Wronskian in this case as a minus 4. This is equal to minus integration. X is 32 secant of 2x divided by Wronskian is minus 4 cos of 4x dx. We can also write this is 8 times of, this can be written as 1 upon cos of 2x, and here we can use the formula, that is cos of 2 theta is equal to 2 cos square theta minus 1. Apply this formula here. Rather than 2 we have 4. We can use this half formula here. We have 2 times of cos square 2x minus 1 into dx. So this is equal to 8 times of integration of 2 times of cos 2x minus 1 upon cos of 2x. Now the integration of cos 2x is in terms of sine. This is secant, and secant integration is log of secant plus tan. None of the option is containing sine as well as a log term. It means only D option is correct. Let's take the next example. If y1 is equal to x and y2 is equal to 1 by x are the two linear independent solution of this equation, then the particular integral of the given differential equation is ax plus b into 1 by x. Then what is the value of x? One way is you can solve this with the help of Euler-Cauchy equation and then find the particular integral and accordingly fetch the value of e. Second is, whenever we have this type of a form, like two solution is given to us, and based on these two solutions we are writing the particular integral, it means we need to apply the method of variation of parameter. In this case we need to find the value of a. A means that is minus integration of x upon Wronskian of the functions into, rather than taking x we will take the second function, that is 1 by x. Now what is the capital of x in this case? That is a right hand side function x cube divided by coefficient of second order derivative, that is x square. This is very important to write. In this case this is not a 1. So capital X in this case we have x. Now what is the Wronskian? Wronskian of these two functions. So Wronskian of these two functions is equal to first function x, second function is 1 by x. Derivative of x is 1. Now what is the derivative of 1 by x? That is minus 1 upon x square. Simplify this into this, that is minus x upon x square minus 1 by x. That is equal to minus 1 by x minus 1 by x is equal to minus 2 by x. So in this case, we have the Wronskian value minus 2 by x. Now let's calculate a. Minus capital X is x divided by minus 2 by x into 1 by x dx. This x's get cancelled with x. Negative negative is get converted into the positive. We can write this as x by 2. Now integration of x is x square by 2, and this 2 is as it is. So we have in this case the answer as B option. Next example is, we have taken the same case. Rather than calculating the value of A, we need to calculate the value of B. So here A is always negative and B is positive. So positive integration of capital X divided by Wronskian into, rather than taking the function as 1 by x, we will take x. Now what is the x? X is x cube divided by x square, that is x. And what was the Wronskian? Recently we have calculated the Wronskian as minus 2 upon x. Substitute here, capital X is small x divided by minus 2 by x into x dx. That is equal to minus integration of x square, and this 2 by x is written as x by 2. That is equal to minus integration of x cube by 2. So integration of x cube is x raised to power 4 by 4, and this minus 1 by 2 as it is. That is equal to minus x raised to power 4 by 8. Hence option C is correct. The last example we have, if this is the complementary function of this differential equation, then what is the value of A in this case? Check it. We are getting a two linear independent functions here. Now what are they? If you expand this ycx, that is a complementary function, c1 e raised to power minus 3x plus c2 x into e raised to power minus 3x. So this is the value of y1 and this is the value of y2. Here we need to calculate what is the value of a. It means we can expand this a times of e raised to power minus 3x plus b times of x e raised to power minus 3x. So how we can calculate this a? That is minus integration capital X divided by Wronskian into, rather than e raised to power minus 3x, we can write x e raised to power minus 3x, this function, dx. Now, what is the value of capital X? That is e raised to power minus 3x divided by x, divided by Wronskian, x e raised to power minus 3x dx. Let's calculate the Wronskian in this case. Wronskian is calculated as, first function we have assumed e raised to power minus 3x. Second function is x e raised to power minus 3x. Derivative of this is minus 3 e raised to power minus 3x. Here we need to use the product rule. First function as it is, derivative of e raised to power minus 3x. That is minus 3 e raised to power minus 3x plus second function as it is, derivative of x is 1. Now calculate its determinant, that is equal to e raised to power minus 3x into this whole term, that is minus 3x e raised to power minus 3x plus e raised to power minus 3x minus this into this, that is minus 3 e raised to power minus 3x into x e raised to power minus 3x. This is equal to minus 3x e raised to power minus 6 of x. Because the base is same, we can add the powers, that is minus 3x is equal to minus 6x plus this into this, again the base is same, we have e raised to power minus 6 of x. Negative negative is a positive, 3 into x, base is same, we can add the power, that will give you minus 6 of x. This is a negative sign, this is with the positive sign. So these two terms are get cancelled. We have e raised to power minus 6x as the Wronskian. So here we can write e raised to power minus 6 of x. This is equal to. Here x is get cancelled with x. Numerator term is e raised to power minus 6 of x because base is same and power is added, divided by e raised to power minus 6x. Integration, this negative sign as it is, dx. Again we can cancel this one. We have minus 1 of the integration dx. That is equal to minus of x. Hence option B is correct. So whenever we have such type of questions where we need to find the coefficient a or a b from the particular integral that is mentioned in terms of a complementary function, like here we have c1 plus c2x e raised to power minus 3x. So these constants are replaced by a and b. Similar term we have here. In such cases, we need to apply the method of variation of parameters to evaluate the answer.